Since we have EDPs tomorrow, I decided to go ahead and go through a few of the review problems on the board and make a recording of it. So we'll see how this works for you guys. I'm just going to go through a few of the problems from the review. We're going to start with problem number 2. So it wants us to write the equation for the polynomial that fits the graph and the points that are indicated. And then it wants us to state the domain and the range. All right, so here we go. So the first thing we want to do is we want to look at the graph. So we see that it has 4 distinct roots, right? So we know that it's a 4th degree polynomial. We're going to go through each one and find the actual root and their multiplicities. So we have a root here at -4, right? So we know that the root is x equals -4, and it has a multiplicity of 1. So we have a root here at x equals -1, and that has a multiplicity of 1. We have an x at 0 with a multiplicity of 1, and an x at 5 with a multiplicity of 1, right? So we're going to go through now, and we're going to write the equation based off of their the actual root and the multiplicities. So our general equation is going to be y equals a. Right, so we need to figure out what that stretch or shrink factor is. And then now we're going to write these roots in factored form using their exponents from their multiplicities. So this will be x plus 4, right, with a multiplicity of 1. So x equals -1, so x equals -1 will be x plus 1 with a multiplicity of 1. At 0, x plus 0 or minus 0 or just x with a multiplicity of 1, and then the factor x minus 5, right, from this root x equals 5 with a multiplicity of 1. So then we're going to use the point that they indicated, right? They gave us the point 1, -2, so they're using this point right here. So they're going to plug 1, -2 into the equation. So we say -2 equals a times 1 plus 4 times 1 plus 1 times 1 times 1 minus 5. And then now we're going to do the math. So now we have -2 equals a times 5 times 2 times 1 times -4. So it gives us -2 equals a times, see, 5 times 2 is 10, times 1 is 10, times -4 is -40. Divide by both sides by -40, and you get 1/20th, right? And that's going to equal my a value. So now I'm going to plug my a back into this equation. So I'm going to plug it back in here for a and write my final equation. So the final equation is y equals 1/20th, right? And then my factors x plus 4, x plus 1, x, and x minus 5. So that's my final answer. So this problem is the same thing. It's just asking us to write the equation that passes through the point. They just gave it to us in a list of roots with their multiplicities, and they want us to give us a sketch of the graph. So let's go ahead and sketch the graph first. So first we see we have a multiplicity of 2, 1, and 3. So we're going to add their multiplicities to figure out what the degree is. So we have 2 plus 1 plus 3, which gives us a degree 6. So we know this is an even-powered function, right? So we don't know if the graph, if the actual a value is positive or negative. So in order to find the end behavior, we're actually going to have to find the equation first. So we're going to have to find the a value, and then we can sketch the graph, okay? So we're going to say y equals a. And now we're going to write their factors. So if we have a root at x equals -3, then that's x plus 3 for its factor. Has a multiplicity of 2, so we square it. Oops, sorry. All right, so here we have x equals -2 with a multiplicity of 1, so that's the factor x plus 2. All right, and then 4 with a multiplicity of 3, so that's x minus 4 with a multiplicity of 3. And now we're going to put the point 17 through. So we say 7 for the y value and substitute 1 in for the x. So a equals 1 plus 3 squared times 1 plus 2 times 1 minus 4 cubed. All right, so that gives us 7, right, equals a times 4 squared times 3 times negative 3 squared, or cubed, sorry. So that gives us 7 equals a times 16 times 3 times negative 27. So then now we're going to take 16 times 3 times negative 27, and we get negative 1,296. So we're going to divide both sides by that. So now I have my a value. So now I know my equation is going to be y equals 7 over 1,096. We know that's negative. And then our factors. All right. So now we know that our end behavior is negative. So since it's an even degree polynomial with a negative a value, we know that it's going down here, right? So then now we're going, our end behaviors both going to negative infinity. So we have a root at negative 3, right, with a multiplicity of 2. We have a root at negative 2 with a multiplicity of 1. And then at 4 with a multiplicity of 3. So now we're going to go ahead and graph this. So we're going to come up, we're going to bounce off of here because it's a multiplicity of 2, come down, go back straight through negative 2, right? And then we're going to come down and we're going to curve right through 4 and then go straight down to negative infinity. All right, so then this one, it says using a graphing calculator to graph the function, it wants us to sketch the graph. So once you get that picture on your screen, you can sketch it. And then find the zeros of the graph and the end behavior and the domain and the range. All right, so here we go. So you put it in your calculator and you get a sketch. So I put it in the calculator already and sketched it out. So you transfer the sketch onto your paper. So what are the zeros? Well, we can see the zeros are at negative 2, 2, and then we don't know what those values are, but you can use the graphing calculator to find those, or you can use synthetic division in order to find them. I'm actually going to do that just so I can show you guys practicing how to do that on more than just one equation. So I did not find those zeros, so I'm going to find them algebraically, right, using some math method. So here's our sketch. So we know our zeros are at x equals negative 2 and x equals, what did we say that was? Positive 2. All right, I'm going to use synthetic division in order to find this equation. So remember to use synthetic division, we're going to put our first number through, so x equals negative 2, put that through, and then put our leading coefficients in, so we have x to the 4th degree. We don't have an x to the 3rd, so we substitute a 0 in for x to the 3rd. Our x squared term is negative 40. We don't have a 0 for our x to the 1st term, and then our constant term of 16. So remember, you have to hold your places for the missing terms. And then now we're just going to use synthetic division. So we bring the 9 down. We multiply negative 2 times 9 gives us negative 18. Combine like terms, negative 18. Negative 2 times negative 18 is a positive 36. Combine like terms, you get negative 4. Negative 2 times negative 4 is a positive 8. 0 and 8 is 8. Negative 2 times 8 is negative 16. And then we get a 0, which we should have. That shows us that negative 2 is really a 0 of the function. So now I'm going to go ahead and put 2 through because we said that 2 is also a root. So I'm going to continue on with this problem and put the 2 through. So we bring down the 9 again and we go through the whole same process. 2 times 9 is 18. That gives me 0. 2 times 0 is 0. That gives me negative 4. 2 times negative 4 gives me negative 8 with a remainder of 0. So that shows that, that 2 is also a 0. So now I'm just going to go ahead and finish this problem. So now I started with x to the 4th. I found one of the roots, so that brings it down, this one down to x to the third. So then now this here, so this would be my x to the third. I found this root, so this one is now x to the second. These are my coefficients, so this is going to be 9x squared plus 0x minus 4. So that's the quadratic equation. We're just going to solve that in order to find those other two roots. So in order to solve this, we're just going to add 4 to both sides. So we have 9x squared equals 4. I'm running out of room. So we divide both sides by 9. We get x squared equals 4 over 9. Take the square root of both sides. I think it says x equals plus or minus 2/3. So that means our roots are positive 2/3, x equals negative 2/3, x equals 2, and x equals negative 2. All right, so those are our zeros. As far as the domain is all real numbers. So remember, the domain is the x's, so every x value is here. So we have the domain is all real numbers. Right, so then the range. Remember, our ranges are y values. So it's going to be our lowest value here. So it looks like it's around, oh, that's not negative 3. 1, 2, 3, 4, 5. So it looks like it's probably, we could use our minimum feature on the calculator to figure out what this minimum value is here, but it looks like it's about at negative 26. We're going to go with that. You guys can verify that on the calculator. So if this was negative 26, then the range would be from negative 26, right, included to infinity, positive infinity. All right, so number 10. So writing a coefficient and constraint matrix of the highest degree polynomial for these particular points. So we have 1, 2, 3, 4, 5 points. So the highest degree this can be is a 4th degree polynomial. So we're going to write a matrix for a 4th degree. So that means we're going to have an x to the 4th, an x to the 3rd, x squared, x to the 1st, and then our x to the 0 column. And then we're going to go through and remember, we're going to raise it to the -1 and times that by our constraints, our y values, right? So our y values are going here and our x's are going over here. So we take the first point through. So we have -3. So -3 to the first power is 1. So then -3, 9, -27, and 81, right? And then our y value is -24. So -2. So -2 squared is 16. -2 to the third power, -2 to the fourth power is 16. -2 cubed is -8. -2 squared is +4. Then we have -2, 1, and +24. So -1. So remember, anything in an even power row, so these rows right here, even power rows should not have any negative numbers in them. So this would be 1, -1, 1, -1, and 1. So 0, so 0 is going to be 0, 0, 0, 0, 1. And 1 is going to be 1, 1, 1, 1, and 1. And then we put our y values, so we have 16, 6, and 0. So then you're going to multiply those through, and those are going to give you your coefficients for your final answer matrix. So this will be your A coefficient, B, C, D, and E. So when you finally put this in your calculator and you write out the equation, you'll have y equals ax to the 4th plus bx to the 3rd plus cx squared plus your dx plus your constant term, which here is E. And then the last problem, oh no, we have 2 more problems. So we'll do one with long division and then one synthetic division. So remember long division, we make our long division sign. We put our divisor outside here. And then now we're going to go ahead and divide this. So we say, what times x squared will give us a 4x, or x to the 4th degree? So x squared times x squared gives us x to the 4th, so we're going to multiply this by x squared. So we say x squared times x squared plus 1. Well, that gives me x squared, or sorry, x to the 4th plus x squared. So now I'm going to put that underneath here. So I have x to the 4th. I'm going to put it underneath this like term. So x to the 4th plus x squared, right? So we're going to draw our line and change all of the terms' signs. And then we're going to combine like terms. So negative 4, our x to the 4th degree minus x to the 4th degree is a 0 pair. So negative 3x to the 3rd, we're just going to bring that down because there's a 0 here. So negative 3x to the 3rd and 0 is negative 3x to the 3rd. 2x squared minus x squared is 1x squared. And then we're going to bring down our negative 8. So then we say, what times x squared will give us negative 3x to the 3rd? Well, that's going to be x, or negative 3x. So minus 3x. There's not an x term up here. You could have held its place by putting a 0 x if you'd like to. You don't have to. So now we're going to take negative 3x, and we're going to multiply that through x squared plus 1. So distribute that through. That's going to give us negative 3x to the 3rd minus 3x. So now we're going to put those underneath their like terms. So negative 3x to the 3rd minus 3x. So we're going to draw our line, change all of our signs. Oh, that should be over here. And then now we're going to go ahead and combine like terms. So negative 3x to the 3rd and a 3x to the 3rd is a 0 pair. 1x squared, we're going to bring that down, so it gives me x squared. I don't have so I have no x term, so I'm going to bring that down, so plus 3x, and then my negative 8. Right, so remember we combine like terms. So then now we say, what times x squared will give us an x squared? Well, that's going to be plus 1. So now I'm going to add 1. And now I'm going to take 1 through. So I'm going to say 1 times x squared plus 1. So that's going to give me x squared plus 1. So I'm going to put that underneath here. So x squared plus 1. Again, we're going to draw our line and change all of our signs, right? And then combine like terms. So I have x squared minus x squared is a 0 pair. So I bring down my 3x, and then negative 8 minus 1 gives me minus 9. So then my final answer is going to be x squared minus 3x plus 1 plus my remainder of 3x minus 9 over x squared plus 1. That's our final answer. All right, so then now we're down to our last one. So here we go. So synthetic division. So we're going to go ahead and divide by x minus 5. So remember with synthetic division, we have to hold its spots. So we make sure every term is accounted for. So we have an x to the 3rd, so 1x to the 3rd. Minus 8x squared plus 17x, and our constant term of negative 10. So it says we have a factor of x minus 5, so we solve that, right? In order to get what the 0 actually is. So the 0 is actually 5. So we're going to divide by 5. So we're going to bring our 1 down, right? Our leading coefficient down. So 5 times 1 is 5. Negative 8 and 5 is negative 3. 5 times negative 3 is negative 15. Negative 15 and 17 is positive 2. 5 times 2 is 10, and that gives me a 0. So that means that 5 is one of the roots. It's one of the x-intercepts. So then now I'm going to rewrite this into the equation. So I have 1x squared minus 3x plus 2. And it just wanted us to divide, so then we're just going to finish writing our answer. And then so we're going to have, we have no remainder, so this is my final answer. X squared minus 3x plus 2. All right, and then our last problem that we'll go over, it says find all the real and complex zeros for the polynomial function. You may use your graphing calculator. So we have a 5th degree polynomial. So if we have a 5th degree polynomial, then that means that we have 5 roots, right? So you're going to want to use your graphing calculator to help you get started with that. So here's a picture. It's not the best picture, but it looks like on this that -1 is a double root. It actually looks like it might be a 4th root. So, but let's see. So here we go. So if we think that x equals -1 is a root, we can test that by plugging it into synthetic division. We also know that since our constant term is 1 and the leading coefficient, or the constant term is -5 and the leading coefficient is 1, we know that all of our possible roots are going to be plus or minus 1, right? Plus or minus 5. Like those are my only possibilities. Right? So I can have -1, 1, +5, or -5. So we're going to try -1. So we're going to go ahead and put it in the synthetic division. So I'm going to put -1 outside because that's the root. So we don't change it because that is the actual x-intercept. So we have 1, -3, -8, -2, -9, and -5. So I have every term is accounted for, so we don't have any placeholders. So now I'm going to use the synthetic division. And sure enough, we get a 0. So now we know that that is one of the roots, right? So we could check to see, well, it looks like it's a double root, so I'm going to try and go again. So I'm going to take -1 through again. So again, we're going to bring down our 1. 1 times -1 is -1. And sure enough, it is a root. All right, so now we started with an x to the 5th. So when we found this one, this is now our x to the 4th. So this would be x to the 3rd. I need a quadratic in order to be able to solve this, or we need to see if we can factor. So from here, I'm going to see if you guys can go ahead and try that. So I'm going to pause this for now, and I want you guys to test to see if you can put that back into an x to 4th degree and see if you can factor it, or see what do you think we should do next. You can test to see if 5 or -5 works. You can test to see if 1 works, and then I'll come back with the final answer.